Hey there, so this is section still 2.1, and I'd like to take a look at the symmetry portion of the notes in this section. We know what the word symmetry means in our own English language, but in math we have a couple of different types of symmetry. We're going to talk about 3 today, but then later on in the semester we'll talk about a different type of symmetry. But for now, let's talk about symmetry with respect to the y-axis. Now, if you'll notice over here, I've drawn a picture of our squaring function, our squaring parent, and this has symmetry with respect to the y-axis because the y-axis is the piece of the graph that acts like the mirror. The parent is the same on both sides of the y-axis, so the y-axis is my mirror image. I've also marked here 2 points that are mirror images of each other, and we would probably call this point here the coordinate 1, 1. Not probably, we would. And this guy that's the mirror image is going to be the coordinate negative 1, 1. Now notice that the x values are opposites, but the y values are exactly the same. And that's going to lead us to what to fill in the blank here. If a graph has symmetry with respect to the y-axis, then that means f of x is going to be the same thing as f of negative x. Notice when you write this down that my x's are opposites, but my y values are both positive in this case. My y values are exactly the same. They're equal to each other. This is also called an even function. So anything that has symmetry with respect to the y-axis is going to be an even function. Next, we have symmetry with respect to the origin. And again, you'll notice here that I've got my parent. This looks like the cubing parent. And if I look over here, my 2 coordinates that I want to pay attention is this one here in the first quadrant, the coordinate 1, 1. And the second coordinate, it's not a mirror image, but it's a rotated image. So if you can imagine that I take my graph and I rotate it upside down, then this coordinate will actually be rotated to right here. And this coordinate we know is negative 1, negative 1. And in this case, you see that both the x's and the y's have opposite signs. So this will lead us to fill in our next few blanks. F of negative x is going to be the same thing as negative f of x. Notice that the x's are opposite and the y's are opposite as well. This is called an odd function. The way that I have students remember this, odd starts with O, origin start with O. So anytime it's odd, it has symmetry with respect to the origin and vice versa. The last one is actually not a function at all. And if you'll take a look here at my last example, this is not one of my parents because my parents all came from the library of functions. They were all functions. This is not a function. It does not pass the vertical line test. And we would say that this coordinate right here is the coordinate 1, 1. And this guy down here is the coordinate 1, negative 1, where my x's have remained the same, but my y's are now opposite signs. And so if a function has symmetry with respect to the x-axis, then f of x is equal to negative f of x. And again, it's not a function.